you to get really close to the microphone.
It was muted.
It was muted.
Not big.
Now am I mic'd in the room too?
Yes.
In the room too? Okay. 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 Where were we? Oh yeah, I hadn't started yet. That's right. So we got all kinds of people here at the con talking about problems in InfoSec. But very few of these problems have easy answers. Some of these people have easy answers. Some of these people have hard answers. Some of these problems, people are just here to complain about, complain about the problems. So we're going to talk about developers as a problem, and we're going to talk about some solutions. So we're going to talk about the art and science of communicating security requirements to your development staff today. This isn't a problem with a lot of easy answers, but at least I come with some answers for those of you who are dealing with trying to talk to us in any kind of sensible way about security. I'm gonna explain some problems from my position, which is sitting in the middle, and then I'm gonna try to lay out some solutions. If you come up with a question during the middle section, write it down because I probably answer it in the second section, all right? So the problem is that we're telling the developers that no matter what their QA and their dev say, their code sucks. And as it turns out, they really don't care to hear that. They don't like that at all. And in fact, it makes them quite cross. And we've been doing it for so long now that we've created a schism between information security and the development staff, which is a real problem. So we're going to talk about solving that because of this. A striking 86% of recent breaches were due in some way to an application security vulnerability. Okay, now some of the code is more oblique. Maybe you bought it instead of writing it yourself, but still someone had to write that code. Someone has to communicate to those developers what a security requirement is and what it means. And unfortunately, that person is us. I'm going to refer to us a lot in the talk, both referring to myself and the developers and myself in security, because that's what I do for a living, is sit in that gap. So it's going to get very confusing, and I apologize in advance. So who the hell am I? Probably some of you know me, since I'm actually speaking in my hometown for once. It seems like I haven't done that in a long time. My name is Bill Sempf. You can find me on Twitter. I hang out there a lot. I love it. It's a global conversation like IRC, but it's easier to search. I'm a husband and father. In fact, I only live about 4 miles from here, which is kind of funny. I am an author. I haven't written any books in quite a while now, but I have maybe 10 published books for the Old Rocks imprint in Birmingham, England, and I think maybe 6 or 7 under Wiley's Dummies imprint. And I very much enjoy writing. Currently, I'm spending a lot more of my time writing blog posts and writing courseware and stuff like that, but it's a wonderful thing. I consider myself a software composer. I got the term from Lauren Ipsum, which is a 136-page kids book about software engineering. If you do not have it, please get it. I learned more in this book than I did in 8 years of college about software engineering. The basic premise of the book is that Lauren walks through this fantastic land where all the individual towns represent a paradigm of software engineering. So there's the brute forcers, where people stack stones on top of stones to build their buildings. When they collapse under their own weight, they stack more stones on top. And then there's the composers. And the composers have these beautiful towering spires, this elegant communication system, because they make beautiful things out of beautiful things, which is very much what I like to think that I do. If anybody here heard Jack Daniels on the Shoulders of Giants talk, that's where I live my life. I spend a lot of time standing on the shoulders of giants. More recently, though, I'm an application vulnerability analyst. Doesn't even fit, does it? So I'm a pen tester. I see there's a difference between pen testing and application vulnerability analysts. Pen testers have to have a specific goal, and they have to find it and then write how they got it. Vulnerability analysts take one app and find all the security problems inside that app, and then write them all down, which is both harder and easier. I mean, we have more tests to do, but it's less likely we're going to go to jail. So that's a benefit there. Personally, I am a home brewer. I didn't bring any with me. I should have. A lock picker, lock sport meetup Wednesday. Hopefully we'll have the law guy in. He's actually moved out of state, but he's going to do a Google Hangout with us if he actually emails me back. If not, we'll have a conversation about law. I am a ninja. Nobody throw anything, okay? And I've known to be, I'm known to be something of an insurrectionist in the development circles. As it turns out in the security community, I'm kind of like a pussycat, but that's okay. So let's start off with a large collection of things that are wrong. Please don't get depressed. It will get better. The talk will get less depressing as I go on, so do not immediately get depressed. We have a breakdown in communication that I mentioned before between information security and the programmers that make all of our stuff. There's a couple of reasons. First of all, security is concerned about risk, whereas developers are concerned about usability. And there's a significant gap there between those two topics. Second, security sees things in terms of the vulnerabilities of the software. Developers need to think in terms of defects in software, which is surprisingly a much bigger gap than you think. Third, security has this unnatural shock talk vocabulary about practically everything. Everything is a disaster, you know? Oh, caching is turned on for this page, we're all gonna die, that kind of thing. And fourth, there's something of a culture break between the people that make up information security and the kind of people that end up in development. So let's go into each of those individually, but first I will point out to you that this next few minutes of the talk is something of a rant, and I apologize for that. We will get to solutions at some point, just not yet. So, the first problem is risk and usability. It's been a long-running debate going back well before the internet regarding security. Security has become the Department of No. And I'm sure you've heard that many times before, not just in application security, but application security is one of the people that is suffering from that in a large way these days. For example, when a user logs in, devs just want to help. They just want to make it easier on the user. They want the user to be able to know whether they misspelled their username or their password, or maybe see their password, just something so they don't get as many help desk requests. But we say, who are you? I don't even know who you are anymore. We can't do that username enumeration. And the developer's like, dude, I just want to help the users. So there's where the gap is. Clickjacking is another thing, right? We say, didn't you see Kaminsky's talk? It's everywhere. They're taking over the world. And they're like, but people need to be able to frame the site. That's kind of one of the things we want them to do with it. So we've got to make it easy for them to do it. You know, insufficient input validation, for an example. You know, but Burp flagged it. Yeah, but it's in an API. It doesn't matter. No, you've got to fix it. So then thousands of hours are spent doing input validation on something that doesn't actually matter that much. And all these crypto vulnerabilities, right? Poodle and SSL v2 and v3 and RC4 and the weak elliptic cipher and all these things. Who's going to decipher that traffic? I know it's possible technically. The NSA is going to decipher that traffic? Come on. I mean, who's really going to decipher the traffic? Who's going to take the time to do this? I mean, a phone call to the help desk. A phone call to the help desk is 100 billion times more effective at stealing secrets than decrypting SSL v3. Okay? Yet, PCI marks it, so it's got to be a high, so everyone has to drop everything to fix it, and you wonder why the devs hate us. So vulnerabilities and defects. Now, this is a little bit not so much our fault. There is language barrier. Devs need to be talking about bugs, about defects, not about vulnerabilities. They are used to tracking flaws in software. Cross-site scripting is not a flaw in software. It is a vulnerability. Insufficient input validation, insufficient output encoding, that is a flaw. So I'm not here to give you that big list of things that need to be translated, but the translation must happen. It's true, some developers do want to know why. It's the same reason I get to teach lockpicking everywhere I go. People like a little bit of forbidden knowledge. It's comforting to them, they enjoy it. That said, really what they need to do is take the flaws, put it in their bug tracking system, and fix them. So they need to be told what the defects are, not what the vulnerabilities are. So I mentioned we have something of a shock jock mentality about severity. We label the severity to get the attention of management. Turning in a report with 1 high, 2 mediums, 42 lows, and 76 best practices does not get anybody's attention. So we label freaking everything high, so now high means nothing anymore. Do you know how few, I forgot it was being recorded, how little developers care about the RC4 cipher? About that much. This is just indicative of a much larger problem with severity, though, okay? They think we're crazy. I kind of think we're crazy. All right, you get the idea? Severity is a serious issue, and we've made it worse. Now we have to rate everything high to get any attention. And if we back down now, there's got to be some communication take place. Speaking of which, this is a tougher problem to solve, but there is something of a culture rift, okay? Sometimes you find out that two categories of people just don't have enough in common to have a meaningful conversation. And if you don't know who these two people are, this is Chris Nickerson, and this is Scott Hanselman, two of the poet laureates of their respective security here and developer here, of their respective sides, couldn't be more different. I mean, seriously, if we put them in a room together, something would just spontaneously catch fire. So it's really amazing how different the two communities can be at times. So that culture divide lends itself to another whole category of problems. We have a different language. As a community, a department, whatever, we're just not speaking in a language that our customers, who are the developers, by the way, we're working for them, we're not speaking in a language they understand. So have you ever sat in a readout call and remembered that the reflected cross-site scripting was in the last 3 reports that you did with them? It was in the 2015 pen test, it was in the 2014 pen test, it was the 2013 pen test. Why don't they just fix it, right? Well, as it turns out, programming is really hard. It's really hard. Have you tried it? How many people here could go back to the office, check out a branch of their core product, not you, check out a branch of their core product, fix something and compile it right now? That is not nearly enough of you, okay? You need to know how to do this, because programming in Python and Notepad for 10 lines of script working from something you copied from Stack Overflow to get something done is not the same as programming in a corporate environment with source control with 15 people looking over your shoulder all the time. It's way harder than you think to do this work. So that's why it doesn't get fixed. There is also a schedule. There is a schedule to software development that you do not control. If you do not understand it, and you simply drop a report on a developer's desk and say, fix it, you'll get this. There is a pattern. There is a pattern to software development that cannot be ignored by anyone. And project managers keep that pattern in place. If you do not work with those people, you will not get listened to. Your work will not get done in time. You need to understand your platform, what it does well and what it does poorly. Hopefully, most of you could tell me whether or not you are primarily a Ruby shop or primarily a .NET shop or primarily a Java shop. If you do not know that, that is step 1 when you get back to the office tomorrow. Knowing what you're talking about makes you sound like less of a dick, okay? So learn your platform a little bit. Also, find out what your platform might do well. Ask.NET is remarkably good at preventing cross-site scripting out of the box. There are some bypasses in place. It doesn't mean you're not supposed to do input validation, but it's pretty solid. It's pretty solid. So we know what the problems are we're faced with, right? We've got a culture rift, we've got this language problems, we've naming and severity issues, there's the lack of mutual understanding. So the question is what are we going to do about it? And I will tell you after I have a drink of water. So there are 3 things you need to focus on tomorrow, if you're going back to the office tomorrow. First is automation, right? Getting as many things off of the plate of the developers from a security perspective as humanly possible. The second is find the things we shouldn't automate and make sure there's a position to do them manually. And third is honing these relationships we talked about in the first section a little bit. This is not unlike the social engineering stuff that we talk about all the time. Maybe not all of us are red teamers, not all of us practice it, but all of us have been in talks about it. All of those skills we learn as social engineers, even though many of us are socially inept, myself included, certainly, All those skills we learn as social engineers will apply when attempting to communicate these things to developers. But first, let's automate everything we can automate from the application security perspective, okay? So much of this stuff ends up getting done by hand or not done at all because we're having machines do the wrong things. All we need to do is script it and forget it. Keep that in mind. So for starters, let's make sure the devs in QA have the tools to get the job done. One of the smartest things I've ever done for any of my clients, I've been doing it all of them recently, is giving Z attack proxy to QA. I go in, I do my basic application security training, then I go back in and do my demo training where I walk through how to use Zap, we just sit and do exercises in WebGoat. And then I go through the corporate channels and get Zap approved for QA people and show them how to test for the basic stuff they can test for. Test for insufficient input validation. Test for insufficiently random cryptographic values. All those things that can easily be handled by a script or a piece of software for them, get QA to do the work. They love it. They love it. To a person, they love it. Best thing I ever did. The next thing you do is build deployment scripts. Okay? All of those information disclosure vulnerabilities and piece of junk old code that ends up on your website or on your applications can be gotten rid of if you simply automate away your deployment. Now, if you're running in a more contemporary hip shop and you guys have all got, continuous integration going and like that, fantastic. Review the scripts. Make sure they're only copying over the things that must be moved and nothing else. Take away everything until the site stops working and only put things back. Put things back only until the site starts working again and then stop. So Python isn't just for DevOps either. Programmers can make use of the whole language and its community to do all kinds of little security-related tasks internally, checking things that they do as well. So giving the developers the tools to do the work, exposing them to that community is a key piece. You need to understand that automatic, static analysis is good at some things, okay? So we need to automate some stuff. Static analysis is a great place to start. So developers hate static analysis, okay? It's often used for style checking. And if you get any two devs in a room, they will disagree on coding style. So when you say static analysis, everybody's going to go, oh. That's understandable, but you're going to have to deal with it. There's a number of good tools out there that are expensive. There are no good tools out there that are free. That is the problem. This is an investment you end up making. I've worked with Veracode. I've worked with Fortify. I've worked with Checkmarks. They're all actually pretty decent at finding the things they can find well. It's the other surrounding stuff that makes the difference. If you don't want to put your code up in somebody else's server, Veracode's out. If you need a community hub or central integration is very important for vulnerabilities, Fortify is your best bet. Really expensive, but your best bet. Checkmarks is really solid for small teams. You just have to do your own analysis or hire a consultant to do it for you. Not that I've done it 30 times or anything. And make a decision about what static analysis tool to use. So what do they get right? Input validation is by far the easiest thing for a scanner to get right from the code analysis perspective. So we're talking about analyzing the code with an automated tool, right? Automated static analysis, input validation, bounds checking, like fence post problems and stuff. They're very good at finding that. Old crypto libraries, for instance, very easy, hard for a human to find, almost impossible to discover in a pen test. Instantly discover it with static code checking. So know that there is a certain category of vulnerabilities that's well discovered by automated static analysis. But you need to understand you can't just throw a 300-page report over the wall. Triage is your responsibility. You need to know the application well enough to sort through it, figure out what's actually important and what isn't, hone the tool, and then sit down with the developers with the actual vulnerabilities that can be related to defects in the application. This is not impossible. I am doing it right now with a huge Java code base using Veracode. And the first time it had ever been scanned, and it came back, got it honed down, and 17 defects out of hundreds and hundreds and hundreds of scan points, because we sat down and looked at the report and figured out what the problems actually were. But it takes InfoSec and development to work together to discover these things. So automated dynamic analysis is also good at several things. How is this different? This is AppScan, or tools that are scanning the application while it's running, not code scanners. So dynamic scanning uses a template to walk through a running web application and find vulnerabilities in active code. Burp Suite has this. You index it by walking through and making a template of the site, and then it'll go through and resend all the posts with trying different things to try to find vulnerabilities that way. It is good at some things, but not everything. Output encoding, it's great for that, right? Command injection, stuff like that, or cross-site scripting. It shouldn't say command injection because that has nothing to do with output encoding, but that's okay. Information disclosure, okay? Very hard to find manually. Sometimes hard to find on a pen test, but extremely easy for an automated scanner to discover by looking through comments and headers and whatnot, right? Authorization problems, authentication problems, easy to find with a dynamic scanner. Understand what the tools do well and use them for just that. And then once again, we can't throw a 300-page report over the wall. You've got to know the app and the tool well enough to sit and do triage. So automatic scanning is wonderful, but sometimes a human simply just has to do the job. And that's okay, because we've automated away a bunch of the stuff that we used to do manually. So there's a small handful of things that only the inside of a human mind is going to be able to isolate. Let the machines do what they do well. We do what we do well, okay? So the obvious thing, we talk in the pen testing space. Pen testing is manual dynamic analysis as compared to automated dynamic analysis like the web scanners that we have, right? So only a human is going to look at this URL and say, I wonder what happens if I increment that number. There isn't an automated scanner out there that does that. But every pen tester on the planet will do that. It's an intuition thing. You know that number is referencing a person. You know it is. By the way, do you know what happens if you do increment that number in this API? You get the next person. They're fixing it in V2, apparently. Only a human is going to look up the developer's name in Stack Overflow and find the database password. There is no automated scanner in the world that's going to do that. But every pen tester is going to do that. Everyone worth their salt is going to do that. Okay? You are still going to have to explain the results. The devs are too busy coding to sort through the pen testing results. They need to have it explained to them. All right? So also, keep in mind that those third-party testers, hiring in pen testers, will not always understand your environment. So you need to take that into consideration when you schedule things, okay? Sometimes you can build a long-term relationship with the vendor, and sometimes you can do things internally, but most of the time that report will effectively be from a black box perspective, and you need to remember that when you're relating the results to your pen tester or to your developers. So that was dynamic manual testing. Next we have static manual testing, manual static testing, right? Code review. We have machines looking at code for the things the machines find well. But there are certain things that humans are going to find better than anything else from the code review perspective, right? You need a discrete list of code review topics that you can add to the hopefully already present code review practice that your development staff has. You need to keep it short. Not like the last talk, but short. Sorry. And then have the humans check the things that they can do well, right? Access control, sensitive data handling. Are you following the red data rules for your company? No automated scanner is going to know your rules, right? You need to check that. You need to make sure if your rules say social security number gets masked, that it's masked. No scanner is going to check that for you, okay? Secure service calls, communication between applications. Not something that is going to be easy to find in pen test or easy to find with an automated tool, but the manual tools, manual code review will bring it out. And of course, making sure you're following your logging practices. These are all important things that need to be found by humans looking at source code. The developers can do this work. You do not need to do this, but they need to know what to look for. So one thing that people can do very well is look ahead and fix problems before they occur. Okay? There is actually a list for that, and it encompasses much of what we're trying to talk about here in this talk. It's the Proactive Top 10. It just released v2.0. So what I'm about to show you on this slide is probably not completely accurate anymore, and I'm very sorry I didn't think to update it. But that's okay. You all know how to use Google, which, by the way, use Google for the OWASP website because the search on the wiki is search for the Proactive Top 10. Jim Manico is one of the people who wrote on it. I can't remember the other guy's name off the top of my head. But it is the OWASP Top 10 written for developers. Notice the first thing does not say SQL injection. It says parameterized queries. That is the defect. Failure to parameterize queries is the defect. It is written from the defects perspective. So here is your toolkit to get started. Once again, it's a top 10 list. It is not an application security program for your company. It is a start, a spark to get you fired up. But a start it still is. So I talked about the digital divide earlier, and there is a real social division between information security and development. But we've got to spend some time together eventually, right? I find a lot of luck feeding developers. Really, it's a great compliment to many, many things. I know it sounds silly, but eat, drink, be happy. You'll find that it's a little bit easier than you think to get things done. So training, for instance, developers listen a lot better when they're fed. So feed them. This is a pattern that's worked very, very well for me, okay? So I start with some security principles, right? Minimizing the attack surface area, establishing secure defaults, principle of least privilege, defense in depth, failing securely, all those principles. And then I turn that into testing your own stuff, right? Teach them the principles, teach them how to test their own work. And then finally, roll that into secure coding. So we've learned the principles, we've learned how to find the vulnerabilities in our own code, now let's learn how to fix them. And then we just redo the cycle. Every year, year after year. People get to hear the same thing sometimes, that's okay. New developers come in, we'll pick them up. Just keep cycling through the slices. Don't have resources for AppSec? Good, there's an organization for that. OWASP, right? The Open Web Application Security Project. Most of you probably have heard of it. If you have not, go look it up. It is a global initiative to increase the visibility of web application security. It consists of three main parts. The projects, like the Proactive Top 10, and Z-Attack Proxy for that matter. Chapters, our local Columbus chapter we're on Meetup. Come look us up. Come visit hang out with the devs for a while. And then they put on conferences. It's called AppSec. AppSec USA was in California. It's going to be in Washington in 2016. So that's not even that far away. This is the organization that is building these standards. They have documentation to help you with what you need. So use them as the resource. You've probably discovered it is very, very difficult to find application security specialists. Like, impossibly difficult. Like, I got 40 emails last week from recruiters looking for people. There aren't any of them. So let's make them. Take the developers and the QA people that like the training, that like learning how to use Zap, and make them into your application security department. You can do it sneaky if you have to. Trust me, the dev leads will not be happy with you taking their people. It's true, they will not be. But if you go at it slowly and don't just go in and say, hey, Bob, you like security, come over to our side and we've got cookies over here. If you go at it slowly, you'll be able to get the work done. That's what you need to do. We need to keep in mind that we're all in this to solve technical problems. We're just approaching it a little bit differently, okay? The developer's trying to make users' lives a little better with better software, and the protector in me wants to make sure they don't get screwed over by the bad elements that are out there, okay? So I'm on both sides of this, and I get along with me. If I get along with me, you can get along with the developers. So social skills aren't any of our things, okay? We didn't get into a technical field because we were great with people most of the time. But I mean, I'm a great example. Those of you in the crowd that know me well realize that I got to go hide in a corner for 6 hours to get over being in front of a crowd for this long. But if you plan right, you can make the connections happen. Step outside the social a little bit and talk about you, okay? We talked about it before. Do you know your platform? When's the last time you fired up Visual Studio? Take the step to get closer to the developers, understanding their perspective. Go back to the office, put the dev tools on your system, ask for read-only access to source control, check out the project and build it. See what you learn. So where does it leave us? So I know I didn't talk about threat modeling in this talk. Originally, the talk was way too long, but as I've honed it down, I've kind of, as obvious, I've gotten it quite compressed. So I need to add threat modeling material back in at some point. But this is the model that I've been using. I've been starting with threat modeling. I go into a company and analyze their applications and look at what the threats are like for their environment, for their use cases, for their applications. From there, I build in training that matches their needs from a security perspective, okay? So we do the training. I talked about the training cycle. We start the training cycle. And then as we roll around, we bring in, make sure that we've got that 4-part testing piece. The automated static analysis, automated dynamic analysis, and then manual dynamic analysis and manual static analysis. Those 4 pieces all getting triaged into a common place that we then can translate into vulnerabilities. Then we go back through the cycle, review the threat model, update the training for the vulnerabilities we're seeing. And that's the cycle we go through. We just go over and over and over it and solving problems. And there's people in the room who are clients of mine who have been through this and can talk to you if they choose to wave their hand at some point. So this is actually largely the solution to the problem. It matches the needs of the environment. In all the interaction that'll take place accidentally because of the sitting down architect to architect and threat modeling, because of the training, because of the triage of what's coming out of the tools, will create those social connections that you need to actually make things work. It's a good solution to the problem. Just got to remember, we're all on the same team. We're just speaking different languages. Sometimes literally, hopefully not. Okay? Think of it as a NATO exercise. Everyone does something else well. Let them do what they do well and communicate the results. It sounds like I'm shouting a bunch of platitudes here, but it's actually true in this case. Okay? Security isn't the developer's first, second, or third concern, and it never will be, probably. And it shouldn't be, but it has to be someone's concern, right? So we all have to give a little. The developers have to give over a little bit to the side of security, and we have to give over a little bit to the side of usability and meet in the middle. I'm Bill Sempf. You can find me on Twitter. I came in way short, which is good. We get to eat lunch early. I will take any questions, any questions you have, and then we can go eat.
You mentioned about the schedule and the life cycle.
Yes.
And that I found it becoming increasingly difficult now because of the more potential agile.
Yes. So there is no difference. The point is, that he was making was that Agile makes it even tougher to schedule things in. There is no difference between traditional waterfall, which isn't even what it's called, but that's okay, waterfall and Agile. Agile is just much shorter. They still have to scope, they still have to design, they still have to do the requirements, they still have to design, they still have to code, they still have to test, they still have to deploy. All the same steps are in place, it's just way compressed. So you have to make sure you have business buy-in to get the use case cards on the table for the defects. If you do not have a defect resolution team, maybe you have time to bring it up to your Agile teams.
I found with the agile, though, with our company work, is halfway through that life cycle, and then it's already starting the next step behind it.
There is probably a platform team, a defect resolution team, because when the button's green and not red, someone has to pick that up as a defect. Find that group. That's the group that fixes the security vulnerabilities.
I completely agree with you, Bill. In regards to what you said,
Thank you.
the language, it's already in the agile
Mm-hmm.
You're a traditional waterfall team, then they switch to agile, or you get agile running in parallel with the switchover, and you approach them with that. That's the answer you get. So when we're agile, we don't have that.
Yeah.
And I say you do, because you're developing something, so you have
That's where you go dig in. That's right.
Themselves, and if you threat model, you do that edge out at the top, at that system level, you have those black boxes that say, hey, you have a threat authorization. Somewhere down the line, someone's going to find that.
That's exactly right. It should show up in the rest of the cycle. Should show up in the rest of the cycle. Yep.
So we're at, we get that.
Yes.
If you're waiting until it's a defect and you have to have them address it, you're missing the boat.
But
Buy-in to be part of the business.
over time.
Business requirements up.
But when you start, you're going to have this big, the first time you run Veracode, it's going to come back with 700 things. And somehow those have to get put into the defect resolution queue. Over time, the training will start to make for more secure blanket coding. And that's why it's beneficial to stick with one analysis or one analysis toolkit, so you see that trend over time and you can watch the defects actually go down, because the developers are actually writing more secure code, which that's the end goal here, is to get them to write, but that's not what this talks about. This talks about getting started. So, yeah, good. Yes. Yeah. Well, because nothing's changed. Nothing's changed. In fact, we do it every 3 years. We're not going to do one in 2016. We're going to wait till 2017 because nothing's changed. The same. We gathered the data, and it's the same exact list in that order. And it's a shame. That's right. Now, there is good news. I mean, injection is still A1, right? But it's not A1 because it's horribly prevalent. I know there are people who twist the statistics and tell you that's not true. But in enterprise development, it used to be that 60% of enterprise quality, so these are applications built on a real platform by a real company, on Rails or on ASP.NET or on JSP or something of that nature, 60% of those applications were vulnerable to injection. And now it's 12. And the reason is because of the proliferation of ORMs, which make it so that the developers have no choice but to parameterize their queries because the ORM's doing it for them under the covers. Thank you. So that's the that's the reality. It is getting a little better, but injection is still so dangerous of a vulnerability. That's why it's still A1. Yeah. Thank you. Yes. Yeah, the question is how do you deal with developers you can't touch? I mean, people that are overseas, totally different social structure like that, and it is very hard. I have a West Coast client who has a development arm in Belgium, and we would do the training, and I mean, I would have to have people type their questions in because their accent was so heavy, I literally couldn't understand what their questions were. It does add a level of complexity to it, and I don't have an immediate answer. But the one thing that I have discovered with my banking client was that they had their consulting group already had a strong security culture. So finding partners overseas that already have an actual strong security culture, if security is a high concern for your organization, which probably it is since we're all here, that's a mitigating factor, but nothing's going to make it easier. It does complicate things, and there is no easy answer. I'm sorry, but yeah. Yeah, that's what. Yeah, that's right. Right.
We onboarded their security leaders that we could communicate with well, and then you evangelize on
Right. So for the recording, the comment was strong process, which is exactly right. That is absolutely a very good way to make the long running problem more solvable. It's still hard to get in. That first step is tough. All right. Thank you all very much. This is me. Go grab some lunch and have a great con. Thank you.